So, Candida, I think we are live.
Yeah, we are live.
Okay. Hi, everyone. All the folks joining in, how are you all doing? It's a pleasant Saturday evening. Please do send your hi so that we acknowledge that you've joined and ready and set to go for the webinar. Okay, so to get started, let me introduce myself. I am Kriti. I work as a senior software engineer at Recro, and I'm part of the Rebase community. And I'm really, really excited and thrilled to host today's webinar, which is Deploy Like a Pro, AWS Cloud and DevOps Essentials for Developers. Here we have the speaker, Somnath Chakraborty, and he's going to share a lot of insights with us. The webinar is brought to you by Rebase by Recro. And I'm sure this is going to be an amazing session because Somnath is going to share with us so many insights on the AWS Cloud and DevOps ecosystem. He's also having a hands-on demo to share with us, so I'm really excited for that. Being a front-end engineer, I have not been so much exposed to the DevOps architecture and the working behind it, but I'm really excited to learn from Somnath here. So before we get started, I wanted to give you a quick intro of the Rebase community. Rebase is a developers community with 3,800 plus developers growing together every day. We are mostly active on Discord, but we also have LinkedIn pages and Twitter so that you can follow us everywhere. So being a developer myself, let me share what are the perks of being part of this community. So first of all is that it is vibrant and you get to learn a lot. Also we share free career guidance. There's interview prep, one-on-one mentorship sessions from tech giants like Google, Uber, Microsoft, and so on. And we also host exclusive webinars and sessions and meetups like one today, and also offline meetups that we just had today at Jaipur. So if you do follow us on all our social handles, we will be posting all our links to the Discord community as well as LinkedIn on our chats here. Please make sure that you join it because I can say myself that I've learned so much from this developer communities. There's so many engagements. You can find friends here. You can find mentors. It's amazing to be part of such a vibrant community who's always there to help you and guide you through your tech journey. So if you're someone looking for a community to learn and want to connect with like-minded people, please do check out Rebase. We will be sharing the links for the same in our chats. So now coming to today's session, joining us is Somnath. Let me give a short intro about him before he proceeds. So Somnath is an engineering manager with 14 years of experience, specializing in infrastructure, DevOps, public cloud, data center operations, automation, and innovation. He has worked with brands like Amadeus, Accenture, and Cognizant, and has been instrumental in driving tech solutions and leading diverse teams. So he's passionate about leveraging technology to solve complex problems and streamline applications. Somnath's expertise spans AWS clouds, DevOps tools, and delivering efficient and scalable systems. So we will be sharing his LinkedIn profile also with you guys. So really thrilled to have Somnath here with us. Again, before we get started, do check out our Rebase community. All the links will be in the section. And in order to make this session a little interactive and, we would really invite you to share your questions, which we will be taking live in towards the end of the session in the Q&A segment. So please keep it as much as interactive, and if you find something interesting, do post it in the comments and let us know so that we are thrilled and hooked onto the session as well. So over to you, Somnath.
Well, thanks a lot, Kriti. Thank you very much. I hope my audio and video is correct. Good. Thank you. And let me first of all say, thanks for welcoming me to the community. It is a great pleasure being here, and I would definitely love that if as many people gets advantage of this, webinar or seminar, as you can say, and if you get at least 10% out of it, and it it enhances your thinking process, or it excites you about cloud and DevOps. My job here is done. So yep, without further ado, let's get started. Okay, just a second. Yes, are you able to see my screen and my presentation?
Yes.
Okay, so let me quickly get started. Okay, so who am I? First of all, I've been in the IT industry for almost 14 years now. I started my career as a COBOL developer and working on mainframes. And it has been it has been a while since those technologies are still there. A lot of people are still in mainframes, and I have been reached out by many people who are still working in the mainframes at COBOL and trying to explore cloud and DevOps. So yes, it is possible, and it is very much in option for people who tries to explore multiple modern IT practices, or the new technologies that are coming up. So I have been with the data center operations for quite a while. I have managed OpenVMS servers across the globe, so that they are quite reliable, they are up and running. And I have also worked with telecom industry, I have worked with education industry, I also have worked with financial domain as well. Then around 7, 8 years ago, I have finally shifted my focus to cloud and DevOps, and embracing of modern new IT technologies. I have led teams which has done successful migrations from on-prem to cloud in multi-cloud environments, and I have been as with MEDS, which is of a travel and ecosystem, travel and hospital, hotels and infrastructure. So that is a product company there, and in their company in MEDS, I was managing a team of big data platform engineers. So we are responsible for all the big data applications or products that is running on the cloud there. And right now, currently, I am an engineering manager at Earning, and I am leading the platform team here in India. Earning is an fintech company from US, and it has got millions of users, and it's an application based company. And right now we are opening up the operations, or the setting up the operations in India, and I am leading the platform team out of it. So yep, just a quick intro that I have worked with Capgemini, Cognizant, Accenture, Amadeus, and now currently earning throughout my experience. And these are few of the certificates that are mandatory for anyone who is in AWS and DevOps. And meanwhile, if anyone has any questions, you can please feel free to put it in the chat. I will take it, or we'll keep a chat in the questionnaire at the end of the session. So, what is DevOps? This is a very simple, very simple question, lot of asked question, and the answer is readily available anywhere in the internet. So that's not something I'll be focusing on today. Today I'll be focusing on how we use it, how we use it in the industry, how the nicks and knacks that we need to keep in mind for DevOps and AWS. And also, I will be sharing a demo or a solution that I have prepared. It is a simple one, I would say, because it is a simple one, but it focuses on one which is not that common. So this time we have deployed the entire DevOps architecture on AWS, solely on AWS, and not using any third-party tool. So you might come into uh, such cases, or in some organizations where they want to stay cloud native to one technology or one cloud itself, and not that much open to open source tools. In that case, it is also good to know how to deploy it end-to-end CI/CD pipeline in AWS native only. Anyway, this I hope will be a setting stone for you to explore further, to know more and explore more on how CI/CD architecture is fit, what are the different components, and also another thing that I've tried to do in this session is that instead of sticking to monolithic architecture like most of the webinars out there that sticks to deploying an EC2 instance and running up a server. I have tried to explore the Docker containerization part because if you understand, and I'll cover that in the later session as well, that industry is moving from monolithic to towards completely containerization, towards a microservice based architecture, because how scalable it is, how easier it is to handle. Initially it is tough, but yeah, uh, industry is moving towards that kind of mindset. So I've tried to cover that as well. Okay, so what is DevOps? DevOps, is I normally say DevOps is a mindset. It is combination. You say it's a combination of software development and IT operations, and it shortens the life cycle on how we are delivering high quality software continuously. So the continuously is very important here. Because CI/CD, integrated continuous deployment or delivery, is very, very important. That it is continuous. You don't need someone to go in and approve something. Everything is automated so that you can focus only on the development, and the deployment takes care by itself. Obviously, still the platform teams are quite important who maintains this entire thing, but it slowly shifts the focus to from system admins to making into a developer centric. So I already covered. So it's more about speed and efficiency. How we accelerate the releasing new features. It reduces the time to market. So you are thinking of something, you're thinking of a product or thinking of a feature. It should be out in the market. It should be ready to be deployed within days, if not hours. So, and quality assurances. So what in DevOps, what we are trying to do is that we're integrating continuous testing and continuous testing integrated into the CI CD as well, so that there are very less chances that we don't deploy broken software, or something that is broken and it's already out. So we tested before deployment, and then during deploy you also do it kind of a phase wise. We can go for blue green as well, so that slowly it takes up, and there is always an option to roll back. And also, yes, it increases collaboration. It breaks down silos of development and operation. Everyone is working together, and I've seen that happening. I'm seeing in the industry right now that development and the platform teams or the DevOps team are working very closely together. Everyone is aware what is going on and how most to integrate. How best we can design the DevOps system so that application teams are able to do their deploy much easily, and how the application teams understand that how better they can design their system so that they are not wasting resources. I will cover again all these things in details in the cost management slide that I have got. Obviously, scalability comes integrated or not integrated. I'll say you have to enable it obviously, but scalability is a very, very big part of cloud and DevOps and microservices, that how quickly we can scale, how easily we can scale. Okay, and obviously customer satisfaction, because of we are able to quickly, as soon as customer feedbacks are there, we are able to release changes as soon as possible. So focusing on AWS, why did AWS come in? So DevOps by itself is good, right? We have got plenty of DevOps tool out in the market. There are thousands of it. But when AWS came in, AWS started giving, as you know, it's a cloud, it has given a one-stop solution for most of the requirement that is there. It gives a wide range of tools, access to wide range of tools. You can be AWS native, or the integration of AWS with multiple tools is also seamless. Okay, if I am seeing the current industry right now, and in my last 4 or 5 architectures that I have seen, uh, cloud, AWS, Azure, everything is working very seamlessly with outside tools. So if I take an example, I'll come that to it later as well. So containerization, Kubernetes, how easily Kubernetes architecture can be integrated with AWS, how the pipeline can be in AWS or the Kubernetes is in EKS, or we are adding Kubernetes solo, we have got customized on there, or a service mesh in there, and how we are targeting that, how AWS infra is the EC2 instances, the ECS or ECR is seamlessly integrated into it. AWS, as well as obviously, I should mention the databases as well, the RDS, the MongoDBs. Okay, these three uh, the storages they are very very robust in AWS, and also most importantly, AWS gives us the option to deploy in multi regions, which is very very important for us to build a robust infrastructure, because we are putting in a disaster recovery, putting it in a multi-region architecture is very very important, because if one region goes down, if something has gone wrong, or one of the set of applications is down, another one is ready to be back up to to give you an uninterrupted service. So scalability, yes, obviously. Again, if you can see, AWS is uh, constantly complementing what the DevOps requirements are. Scalability and flexibility, then automation and integration. The AWS has got really really robust services like CloudFormation and Lambda is serverless. CloudFormation helps us automate the infrastructure provisioning a lot. Okay, as well as AWS has got a very very good security features that are complementing the DevOps. I'm not deep diving into AWS. I'm not deep diving into DevOps because 1 hour truly is very short time to do deep dives in each and every one. But what I'm trying to do is to give you an overall idea. And if there are any questions in more deep, we can go ahead. So I mentioned in the starting differences with microservices and monolithic architecture. So what is a monolithic? As you know, earlier, I can give an example of, I used to work in mainframes, I used to work in OpenVMS, where I used to have a single piece of code which is running on a blade server, which is sitting on an, data center. But if something goes down, someone has to go there to, even switch off and switch on is also used to be manual. Someone has to dive to the data center, a secret data center, and do it. And yeah, it used to take time, it used to consuming, and it is still there. It's not that it is not gone, it is still there. There are industries which depend on such monolithic architecture. There are industries which depends on such reliability that everything they are controlling by themselves. It is not not shared across. They have their own set of security, they have their own set of restrictions who can access all or can have access to data centers as well. Specifically like banks, specifically like banking industry, specifically like finance industry, they are still using it, and probably they will keep using it for now. But something like an application, a mobile app, which needs to scale up very quickly, which has got millions of users, which needs constant changes, constant features. For them, microservices makes way more sense. Specifically, microservices have not only, it's not only mobile apps, but websites, or other other applications which has to do very frequent read write with databases, as well as multi users, multi regions. For them, microservices makes a lot more sense. Or we have got multiple products running on the same infrastructure. Microservices make a lot more sense. In that way, every product or every feature, every product is running independently. All are on the same infra, but every is running independently. Even if it one goes down, others are not affected. Okay. So yes, monolithic is a single unified code base. Microservices are multiple independent services. And scalability, yes. So monolithic, what you do, if you have to scale, you have to duplicate the entire system. You can only scale vertically or horizontally as well. Microservices, we can, you know, we can deploy, you can scale by individual services at all. Deployments, obviously, when you're doing monolithic, you require a full system deployment only when you're doing a deployment. But again, same thing. If you can see, the services are independent; they're all separated, and you can configure independently. Okay, and maintenance as well. So as the deployment is separated, maintenance is also separated. You one is going down, you can update it. If one set of cluster is down in Kubernetes, you can ping it up individually without affecting anything else. So complexity, yes. A monolithic definitely is much easier, to develop initially. It is much easier. You don't have to think of multiple differentiating with services. But as it starts growing, as it starts adding more features to it, as it starts adding more pages or more products to it, it definitely gets complex. But microservices, yes, initially it might be a little more complex, but it is much easier to manage long term because when you see that all are individual services, nothing is connecting with each other. And tech stack, yes. So if you have got a monolithic service, then if you have created it in Python or created it in React and you're stuck to it, but microservices means you have got multiple diverse of technology stacks across the services. So every service can be of different technologies. I have got, I've seen people learning Python, people learning Java, people, they're multi code or multi-language, multi-services studying in the same architecture in the same cluster. Uh, Maybe a different cluster, but the same infra it is studying. Yes, flexibility I have talked multiple times. Yes, it's it is flexible, and that's why industry is moving towards microservices. Now, coming to DevOps, this is a very common picture, and I myself have picked it up from the internet. This is a very common picture. Everyone has seen it, and probably everyone understands it, or might not. So I'll briefly go through it at first. So DevOps, let me see if I can have a pointer. Yes. So DevOps is a part or is a combination of multiple steps. Or as I said, it's a mindset, it's a process. It's not a single tool, it's not a single language, neither it is a single, set of rules. It's a mindset. So we start with the code. Here, the code starts with initial code repositories. We have actually before code we have some plan as well. So Jira Confluence comes in plan, and code you can keep Git repository, or you can keep code commit, Bitbucket. There are multiple code repositories. After that, we are coming to build. Build, we have got AWS code build. If we are sticking to AWS specific, we have got Maven. We have got others. SBT depending on the code or depending on the application you're trying to build. Then there is a testing phase. This testing phase comes in the integration part itself. We have Selenium testing, we have JUnit testing, and these are just two examples. As I said, there are many, which is too many, right now to list out here. Then release. Release are normally Jenkins. CodeShip is not that much used anymore, but Jenkins is the most popular. Nowadays, GitOps is quite popular, as well as Code Pipeline is obviously there if you want to stick to cloud native. Then the deploy part. Deploy part can be to AWS cloud, it can be to EC2 instances, it can be to Azure, it can be to any cloud, it can be onto a Docker containers as well, depending where it is running. So Docker container, I hope many are already aware what Docker container is, but I can quickly go through it, go through about it a little bit. So containerizing an application, so microservices by default mentions that you're containerizing the application, you're putting it and you're putting it into small containers. This containers contains an image of the operating system on which you're supposed to run. So these are quite small. You don't need to have huge operating systems or huge computers running entire applications. These are quite small containers which are running an image of the OS, as well as the entire application can run on it, and if it goes down, it just creates back. So it is quite robust, it stays up. And nowadays, if you see, Kubernetes is extremely popular for Docker containers. So Kubernetes is right now the market leader, which is utilizing all the Docker containers, so the deployment can be there as well. After that, we come to operate. So you know, so so the this is the operations. What do you operate? We can have Ansible for this is mostly a configuration tool where you're doing the final configuration and applying it to Kubernetes, as I just mentioned. It's how I just mentioned earlier. It's definitely very, very popular. Chef is there, and it is still there if we use it. I personally have not used Chef much. Ansible, Kubernetes, definitely. Okay. After that, monitor. And monitor, we have Azure, we have Splunk, and we have Datadog. Datadog is right now one of the most leading in the industry, and Datadog gives you a very, very good insight on all your applications, that which one is running, how much data, how much traffic it is getting, as well as where Datadog is very, very useful to understand how much cost, how much resources each applications are utilizing. So Datadog gives you a very comprehensive architecture. I'll go through Datadog a little bit more in the next slide, and it gives you a very good insight on your entire application. Okay. Now, this slide, before I jump into the code that is being before the demo, uh, I wanted to connect on this. So this is from one of the questions that was shared beforehand, and I wanted to go through this once before we go ahead with the demo. So cost effectiveness in AWS and DevOps. Cost is extremely important when it comes to AWS and AWS architecture utilizing DevOps tools. What happens that migrating to AWS is quite easy, and AWS themselves have made it very easy to migrate into. There are multiple migrating to AWS. As I mentioned earlier, I have led multiple teams who have migrated applications from on-prem to cloud, and there are multiple tools available which helps you with that. There are lift and shift. There is a complete reconfiguration, re-architecture as well. So as I said, there have been instances where you have converted a monolithic to a microservice while moving into cloud as well. Or you do a lift and shift with the entire VM, you just put it in an EC2 instance. But AWS, Azure, anything, any public cloud to be matter, gets very expensive very quickly. If you go into an AWS Cost Explorer and see and check into the usage of the price of the resources, they are quite high. And per month, the cost goes in thousands and thousands of dollars. The bills are there. In fact, yearly it goes into millions. So being in AWS has its advantage. That's why so many industries are already there. It has its advantage. I have already mentioned the advantages of cloud. The availability. You don't need to maintain your data centers anymore. That is a cost savings, as well as it is giving you a multi-region. But it is also very important that we are utilizing it efficiently. Okay, if you are taking EC2 instances for just a simple thing as an EC2 instance, right? I know whenever someone is testing or someone is doing any kind of session or learning, you will do a T2 micro and just run it. It is minuscule, but when you go to instances like M5, M6, and the high compute, high resource instances, they are very expensive. And obviously, running a business has its own expense, and running a infrastructure has its own expense. So compared to that, obviously, it gets cost, but it does not. It for a platform engineer, if you are saying from a platform engineer's point of view, it is very important that we are looking at very cost-effective methods, and we are, you know, having keeping on top of it. Or else it gets out of hand very soon, very quickly. I've seen that happening multiple times, and that's why this points. So, firstly and foremost, right sizing of resources, make sure that you're continuously monitoring and adjusting your instance types and sizes based on the actual usage. Okay, and implement auto scaling to match demand dynamically. I have seen, I was mentioning Datadog a little earlier, right? So it gives you there's a field in the Datadog, or there's a dashboard in Datadog which you can create that gives you a maximum number of, or the percentage of resource utilization, that how much actually you have reserved, how much you are actually running, and how much you're actually using. And there is always a difference. That difference, how much you can reduce, gives you the advantage in cost. So always constantly monitor using services like Datadog, or AWS has got inbuilt AWS Cloud Compute cost compute that gives you an idea how much and how where it's being used, and depending on that user size, or use auto scaling as well. So whenever you have got more demand, auto scale, and when you have got less demand, you reduce. Okay, then use reserved instances and savings plan effectively. AWS has got savings plan. It reduces your cost by 20 to 30% easily, and they will only tell you that okay, these are the number of on-demand instances you are running. Either you go for a reserved instance, or you go for a savings plan. It is going to give you a long-term savings. You have to give a commitment of 2 to 3 years, but if you have got a such an application running, then definitely it makes more sense. Obviously, use S3 is also quite a good place where you can lower your cost, make sure you're utilizing intelligent tiering. So something that is not being used, making into a sending into an infrequent access. If something is that and if it is needs to just logged into here, then it can go into Glacier and give you much more cost savings. Also, cleaning up of unused EBS volumes and snapshots regularly, because EBS volumes stacks up very quickly, and it's just a cost that is a dead cost that is there. Unless you don't need it, just do a regular housekeeping. Implement CI/CD best practices, automation of get done of non-production environment, sandbox. I have seen sandboxes racking up builds like there is no tomorrow, and there are just infrastructure who someone have tested and forgot to, forgot to destroy. So if you are using any kind of ISC tool like Terraform, or using Terraform also, just ensure that after you have done it, you have done a Terraform destroy and brought everything down. And yes, keep an eye on container sizing and optimization. So maybe so applications can give a reserve resource that I need 100 cores, 200 cores of containers with 100 gigs of memory, but probably they are hardly using 2 or 3 cores. So obviously the sizing needs to be much more practical. And, bigger the containers are, bigger your instances are, and it just helps. Okay, and consideration serverless, again, I use instead of reserved dedicated EC2 instances, use ECS Fargate EKS and run containers accordingly. You can, if there are short jobs and you are event driven, then definitely use AWS Lambda. They are very good serverless, just running a job. Suppose, for example, running something like a reporting that runs once every day and does not need any dedicated resources to run. So just have a AWS Lambda job. It just goes in there. It creates a container. It just serverless. It runs the application in a serverless and just generates a report for you, and that's it. You save on a lot of costs that you would have if you're running a cron job on a Linux instance and running 24/7. Yes, use auto scaling effectively to reduce idle resources percentage in Kubernetes cluster. And obviously, cost monitoring and alerts, make sure your alerting is good. You are doing a cost exploration. Datadog is a very good tool. I already mentioned that gives you overview cost usage, as well as AWS gives you the budget options as well. Any questions on this? We can take it at the end of the session. Okay, coming to the demo. As you can see, it is little different. It is not utilizing all the tools in the market because I wanted to show something a little different, that is utilizing completely AWS cloud native applications or resources for your deployment of a microservice architecture. Just a second. Okay, so we have got a source. I'll just go. We have got a VPC overall in AWS. As of now, I kept it one region, yes, is one. We have got a source that's got a from GitHub where we are storing the application code. From me, I've just used a hello world, but all the application codes can go into GitHub. GitHub setting up GitHub with your source of your pipeline gives you an auto trigger option. So whenever a code is pushed in your GitHub, a trigger happens automatically. And then we have code pipeline. I've instead of Jenkins or GitOps, here I have used AWS code pipeline for an entire deployment and utilizing code build for for the building of the for the building steps, building of the container, building of the application codes, and then building a container and then deploying it, deploying on an ECR and sorry, my bad. ECR is where we are storing the image, and ECS is where ECS is the container service. Yes, a container service for the AWS native. So we are deploying it at ECS on which it is running as a task. We have got Docker. We are pulling in the base image from a Docker Hub to be precise. We have got a Internet Gateway ALB which allows the microservice to be out of the open in the internet and other users to join. There are more components here that for this current demo I have not put so that it does not make it way too complex because going through it also takes time. But with the CCS, there will be a DB as well. If this, the containers or the application is directly accessing a database, so the database is always separated from the, from the containers. So the DP, there will be probably a MongoDB layer here where it is connecting to and getting its data from or reading its data from. In some cases, there can be, there will be, obviously I did not mention CloudWatch here. CloudWatch is what which will be monitoring, which is monitoring the entire thing. Okay, so for a demo, let me just get out of it. For a demo, please let me know if you're able to see this current screen as well. Okay, so this is a Terraform. So we never in industry you never go in and create AWS services or resources in utilizing GUI, right? Everything is done using an infrastructure as a code. I have used Terraform as an infrastructure as a code here, and I will go through step by step on how this infrastructure as a code is created. As it is quite simple, but it gives you an idea about all the different components that there are. And I will also point out where you go wrong, where it takes a lot of time, where you get stuck. Okay, so starting with the modules, I'm not going deep into uh, Terraform. If you are not aware of Terraform, then please, there are plenty of resources uh, in in internet to understand Terraform. But I'm taking into account that you already have got a decent idea how Terraform works, how Terraform modules work. Okay. So these are a couple of modules that I've created. Normally in Terraform, every component, every like S3, IAM, EC2s, and then ECR, ECS, everything will be module driven. Since this is a very small example, I have not created that many models, but everything is module driven. And how does it works is that the platform team creates these modules, individual modules, and stores in the repository. And when anyone from the application team have to deploy the infra and almost ready for their codes or the application to deploy to cloud, they can just call those modules in their own Terraform code and pass on the values. Just pass on the repository name, pass on their account where they want to deploy, and maybe some variable details that needs to go in, and that's it. Normally, the application or the development teams will not maintain these modules, and there is an advantage for it. So tomorrow, if I have to, suppose I have to roll out intelligent tiering to all S3 buckets that are there, so the platform team or the DevOps team will just go in there, change it in the module that okay, for our S3 it is intelligent tiering is enabled right now, and they just go in there and run the pipeline, and it gets rolled out to all the applications automatically without much issues, and without even the application or the developers to even know. This helps a lot. This helps in maintaining a complete standardization across the infrastructure, complete infra. So modules are very important, and more it is utilized, better it is. So as you can see, I have done a simple VPC creation. We use resource for creation of any modules, or not modules, or any resources in AWS. We have firstly, this is for a VPC creation. Then we have creation of subnet, there's a public, and we have got a VPC ID, which aws.vpc.main.id, which is taking the ID details from here. And then we are dedicating a CIDR block. We are maintaining multiple availability zones, and we are maintaining that, please put in a public IP on launch is true, giving a tag, and then that's it. Okay. Now, also with VPC, we also need, and I'm just going through the models as of now. We need an internet gateway so that the VPC is able to work outside, outside world is able to log in to the VPC, or able to reach out to your services. Okay. Now, starting with, yes. Okay. So I think this one is depreciated. Anyway, so yes, provider we are using as region US East 1. And after that, we have got our main. So this is our main where we are calling the module, and we are putting in the IAM roles. So what is the design? If you remember, in our design, we have got a code pipeline, which we are doing a source, a build, and a deploy, which is putting in an ECS. So in this code, in this Terraform code, we are not only creating the ECS, the ECR, as well as the other infrastructure like application load balancers, security groups that are there. But I have also, it is also creating the entire code pipeline in this Terraform code itself. Normally, you will see that an infra code is separate and a code pipeline code is separate. But as of now, I have checked, this one is here only. It makes it a little bit more complex, but for a small demo, it is fine. Okay, so for ECS, so we need, first of all, I will go to the IAM rules. If everyone is aware of IAM rules, good. So we need, every application needs IAM rules to be able to execute certain conditions. And this is where, trust me, where most of the issues come, that to define your IAM rules exactly how it is intended to. So as you can see here, I've got a ECS task execution role. So the IAM role that I've got here, the IAM role policy attachment, it gives me the option to invoke ECS task execution policy. After this, we have got AWS Cloud Watch log group. So this is the log group ECS My Service where all the CloudWatches, our CloudWatch group is going to be kept. Uh, all the logs are going to be kept. And after this, we have got the task definition. Okay, these are the ECS task definition. This is what defines the task that is going to be in ECS. I'll go in depth later when I show into the console what task is, how it is running. So I'm running a Fargate task, which is at the BBC, the CPU of 256 and memory of 512. And as you can see, the execution role, you can see here we define, right? That is the role that I'll be utilizing. And this is the container definition. So how the container that is going to run on this task. So this is the image. This image we'll see later for ACR. And then we have got container port and host port 80 opened, and AWS logs we are putting in group region and stream to these are all the configuration. How best to know how exactly this configuration looks? Go in to resource Terraform and this ECS task definition. There you will have a list of all the functions and what each and every variable means. And then finally, running a service on the task. So this is the service on which the task is going to run. So we have a cluster, we have a task definition that is this. We always need one, we can always make it 2 or 3 depending on our requirement. Launch type is forget, and network configuration. These are the subnet that we created earlier. These are the security groups that we'll be creating later, as well as assign a public IP store so that it is accessible to the net. Now, if I just come by, just mention security groups. So yes, these are the security groups of the service. So we have got from port to port, ingress is open, egress is open. Normally, it will not ingress is fine, egress might not be open to everything. So we'll block it here as application actually has nothing. It is wide open at this moment. So we have two security groups. One is a my service security group. Another one is the application node security group that gets added to the application load balancer. So I mentioned an internet gateway, right? So an application load balancer sits just behind the internet gateway here. Okay. Okay. And we have a VPC subnet security group as well. Now, ECR, this is the ECR repository where we are storing so when we are building, we are doing a build step, we are creating a container, we are storing in ECR. From ECR, it goes into ECS. And this is the ECS, simple, small, this is for the ECS creation of the cluster. And what we are doing with it, you'll come see that later. Anyway, you can see the ECS when the cluster is created. These are the task definition that is done here. Okay, and these are some of the IAM policy. We will go into the little later because I want to go through code pipeline first before defining the all the policies. So this is the major part of this component. This is the AWS code pipeline. So AWS code pipeline, as you can see, are divided into 3 places: source, build, and a deploy. So for any AWS code pipeline to run, we need a bucket, S3 bucket, which it will be used intermittently. So what happens when it comes in from the source? It gets put into a zip file and then it gets stored into the S3 bucket. From this S3 bucket, the source goes into build. From build, it goes into deploy. The interim, everything, it is being stored in S3. And yes, we are maintaining a version control in the S3. And then we definitely need a policy. Obviously, this one hard coded, I'll change it. It should not be an sorry, not hard coded. I mean to say, yes, AWS bucket policy. We need an allow for S3 star, and we definitely need to give the story sources here. many goes wrong because everyone just gives this that we just need a bucket ARN and that's it. We also need to give accessible to the files created inside the bucket. So ensure that you have a slash star or without a slash star as well. After, so this is the S3. Now the code build, the middle part of the pipeline. So code build is always a code build project. Okay, and it runs a container in the backend. As you can see, it is running a Linux container. So whatever code you are getting, it is going to build it there first. So if you have got a container as well, it is going to build it is going to build the Docker container here itself. So these are the two environment variables I'm passing. The environment variable is nothing but the repository URL. This repository URI is the ECR repository. So the code build needs to know that once it is built, either Docker container. So we are getting the application from GitHub. We are building it. Where you are going to store it? We are going to store it in ECR. From there, it will go to deployment. And this is a sample build spec file that is for your code pipeline. Don't mix it with other build spec file that is there, that is the application. This is for your code pipeline. Okay. So we have in build spec, there is always multiple phases. We have an install phase, then pre-build, build, post-build, artifacts. Okay. So phases is install commands. We are just, as of now, I think we just install normally in this build phase. If there is any prerequisite that dependency to be installed, it goes in here. I put in there so that you know multiple phases, the phases of it. There is a pre-build. So the before building, what we need to do, we need to get the login password. Okay, that is the Docker login for ECR, and then this password is coming that is reserved in my system whenever I've done a AWS configure in my current system. And I have logged into ECR. It has been stored in my system, and so that it can uses it. Then we are building a Docker image, Docker build, and we are building the latest image, and then we are doing a Docker push and post build. We are writing the JSON file that okay, it is done, and we are creating these artifacts. Now, this is the code pipeline part. So we did code build. Now the code pipeline comes in. Code pipeline has got three stages: source, build, and deploy. As you can see, we have mentioning that this is the artifact. S3 is being used the artifact that is to store the files that goes from one to another. So first is the stage, the source. So name is name, category, owner is AWS, so and provider is CodeStar. CodeStar is used here to so that it gets it has got a secured connection with my GitHub repository. So whenever I push changes in GitHub, it will trigger the change. Okay, and let me it will trigger the change. Let me do one thing while I will show you so that it will take some time. Let me just go in there and just yep. Give me a quick second. I'm just triggering the bill because the bill takes some time to go. And just let me open a terminal. So I'm doing a git commit, and then I'm doing a git push origin main, and just post it. The latest change went. Now this is the code pipeline. As you can see, the source got triggered immediately. Okay, it just got the trigger, and it got the input from CodeStar connection, and this is the repository that what I just post my changes to, and source. Now let the build run while I continue there. Okay, and yes, code pipeline. We are doing a code build. And then these are the configuration. The configuration I have given my repository ID and the branch name, as well as the connection URL. So this switch you're getting from CodeStar. And then it's doing a build. Uh, the same thing, we are using the buildspec.yaml to do the build, the project. If you can see the project name, the code build project that I just created, I'm just passing it here. And then finally is the deploy. We're deploying in ECS, passing the configuration, passing the cluster name, the service name. These are all the cluster and services that I've created earlier, and the file name. And ensuring that it depends on here so that the ECR is created before this is done. Okay. And if I do a split terminal and let me open something, open this current uh, Terraform demo. Yes, the code is there. So if you, I don't know if you can see, it's quite small. Let me just here. So normally you do a Terraform init to initiate, and do a Terraform plan. So Terraform plan. So as soon as you do a Terraform plan, it is going to see the current configuration, as you can see, and seeing that if any changes have been made or not. And if there's any changes, like here I can see the task definition has changed a little bit. I think with the new task, with you running the task definition has changed, it is just going to do. So if I do a Terraform apply, it is just going to deploy the Terraform apply. As of now, there is no changes, so I'm not doing it. Okay, and final thing, which I should mention, I know we are almost out of time. So we have got a code build also. Every code build, code commit, sorry, code build, code pipeline, and code pipeline role, code build role, code star. Everything needs very, very specific policies, and these policies are very important. How to know what exact policies? It is there in AWS documentation, that if I'm going to build a code pipeline, what are the policies I need? You need to ensure that all your policies are properly. As you can see, there are a lot of policies, and with each and every one of this policy, if they are not configured, you are going to get error. It is very hard to get all these policies right at the very first time, but keep at it, and definitely will be in. Specifically, where it gets missed a lot is this assume role connection. There is an yeah, assume role is a, sorry, there is a trust policy. Okay, it's not here anyway. Probably it is another place. I'll find it. Okay. Yes. So you need to build a trust relationship as well with your IAM role, the user that you are running with. Like, so you are definitely not going to run it using root. You are going to utilize an user to run your code or everything. So that user needs to have a trust relationship built with your code pipeline for anything to work. So that is one thing that many places people get missed. You can keep that in mind. Now coming to AWS console, as I said, the build is still running. So source is done. After this, as you can see, if you click on this link, small link here, you'll see here that it opens an S3 bucket. If you remember, I mentioned that everything is, oh, sorry, this is not this one. Okay, these are the source in the build projects. If you go and then if you open the code build project, you should be able to see all the details here. Here, if you can see, all your build triggers are here, and you can see the source version. Here, everything, whenever you do a build, whenever you, it's just keeps on opening here. Oh, I have to copy it and paste it here. So sorry, there's a source version submitter, and there is a S3. It puts in there, in your S3 bucket as well. Okay, this is just the source. Anyway, let's go back to code pipeline where I want to show you. Going back to code pipeline, this is the pipeline that is running at this moment, and this is the build. So if you click on details, you'll be able to see the entire build that has happened. So it is running a code build. Then if you can see here, it is pulling in the Docker image. Okay, I should have just quickly I missed one. So this is sample application code just to say hello world, and then there is a build spec here. Here you can see we are again installing the Docker container, we're building it, and a Docker file. Here, the Docker file states that what Docker image I need. We have got a Python workdir, and then we are installing, and we are using a Python 3.9 Slim image so that it keeps it low. So we are pulling in the new image. Then we are installing the requirements. Then we are building the container. We are exposing 5,000 board, and then we're running it. Then preparing, and then we are putting it in an S3 output. Let me see if I can see the output here. Yes, the build output. Here, it opens the S3, and you can see the file here. If you go to build output, you will see all the files that has been created. Normally, it will be a zip file. Okay, that contains your code, your build spec, your app.py, your Docker file, your requirements. Okay, so it zipped it, it built it, stored here, and then finally it is doing the deploy. Here, the deployment is having over ECS. Okay, here just go back to clusters. So one is running. As you can see here, my service, if you go in there, this is the service that I have created. And under that is service, there will always be a task. And under the task, here you will see the task that is running. Click on this, and this is the container that is running. Okay, container runtime ID, the image digest. You can see the logs here that what is running in the container. So this is the application code that is running. So if any error goes here, you come here and check the logs that okay, there is a problem. This is where you find it. Okay, I think we are out of time. I'm done actually, and I wanted to keep last 10 minutes for questions if anyone has any. I know we rushed through it, but yeah, covering so much will happen like this way. As you can see, one task is running. If I had to make two, there are two tasks, and if this uh, goes down, automatically another one will get created. Hmm. Okay, okay. Any questions?
I think we have a couple of questions.
Yes.
So I would like to say that it was an extremely insightful session because as a developer, when we make the code commit till the process of taking it live is very much of a black box to developers. But your step-by-step process and showing the demo actually showed me okay how many things are involved till the code commit and the features going live. So let's quickly take a look at the questions.
Mhm.
So first one, I think you mentioned, right, it's very important to define IAM roles and how proper configurations must be set up. So what
Mhm.
are the common mistakes to avoid when working with, AWS DevOps pipeline? What are the things to be taken care of? If you could summarize on that.
Okay, firstly, common mistakes I would say, which I've already mentioned, over utilization or over commitment of resources. We commit a lot. So right now for this application, the container size needs to be very small. As you can see, 0.25 vCPU and zero point 0.5 GB of memory. That's it. But sometimes we just go for a 20, 30 core virtual CPUs and memories of 128, 200 GBs, which actually gets unutilized. So big utilization makes very important. Secondly, the roles are very, very required. You restrict it, you ensure that it is quite restricted. You are building it tight down. Your egress are properly defined. Your IAM roles have got proper policy that it is not allowing anyone else to access your EC2s or your S3s or any resource for that matter outside your intended audience. And thirdly, we ignore disaster recovery. Many times we are focusing on building up the application quickly, but DR is a very, very important step, ensuring that it is multi-region. You have got multi-region deployments, multi-region architecture running. And it is very, very important. I have seen one region, entire region going down, and everything is stopped. The amount of loss in business is enormous. Running a DR, running not only financial loss, your reputation, your everything is on the line. So running a DR is always, running a DR, having a DR strategy to be precise, is always a good, good example to keep in mind.
Okay. So meanwhile, while we go through the questions, anybody who's live watching live, you can still ask questions in the chat. So please keep them coming. So next question, Somnath, is that what is the first thing to check when something goes wrong in your AWS deployments?
Okay. So first thing, if you're running a microservice ECS, then definitely I just showed you the logs. Where is it gone wrong? If a container is crash looping, if it is in Kubernetes, if it is a pod is crash looping, you go in and check in the logs that what is the error, the logs are pretty extensive nowadays, and I cannot stress on the fact that ensure your alerting mechanism is to the point. You don't want to be in a situation where your pods are crash looping or your service is down and you don't even know about it, and some user or someone who actually responds that okay, this is down for the last 1 hour. No? So you make sure that your alerting is in point. So first thing, whenever you get an alert, you go in there and you check in the logs, you check in the from first check the overall. Normally 99% of the time your AWS is fine, your infra is fine, your application containers, your network, or maybe some IP, some new changes come, that's why it gets strong. So, and if there is an AWS outage or an Azure outage or a Google outage, you would have definitely known by now, and it will be on the news automatically. So yes, obviously you have to look into that as well, that yes, some service is down, but 90% of the time it is just your application not able to reach a certain point, or somewhere your networking is what I have seen mostly going wrong, that you're not able to reach a certain place where you're not able to, or maybe some wrong in data and your just code has just crashed. So yeah, that's what my strategy will be.
Okay, cool. The next one is for automation testing. So what are, a few preferred services or AWS things to look up for if you are going in the direction of automation testing or in a DevOps pipeline?
Okay, good question. I just so there are a few standard ones. Okay, there are this lint normally will run, lint uh, to make sure that everything is up and proper. Then we have got JUnits, okay, for testing Java-based projects. Then we have got PY tests, PY test, unit test for Python-based projects. Okay, there are many. You might already be aware, Mocha, Jasmine, they're there for JavaScript
Yeah.
applications. There for Selenium, which are doing E2E, and then there is Cypress, all the Java applications. And then for Docker, definitely Kubernetes is a very good. Kubernetes is their configuration. So Kubernetes has got their own customized. They're not testing, but they ensure that proper Kubernetes, their orchestration is properly defined. If it is going wrong, then it is bringing it up immediately. Okay, and then Sonar Cube is there that checks your code quality. Okay, it just integrates into your pipeline. Then I believe there are vulnerability tests that can be done. Okay, and yeah, but there are plenty actually, but these are the ones that come to my mind at this moment.
Okay. So one more question is that you mentioned about the use of Terraforms and infrastructure as code to a great extent when you're making DevOps deployments or the entire DevOps pipeline. So how would you say, is the importance of learning or knowing Linux for developers? Because for DevOps, like there are many DevOps who are not, who kind of neglect Linux even during their college days. But as a developer also, I can say that it's very important. So how would you say that knowing Linux is important for growing in
Okay.
DevOps domain?
Well, knowing Linux is quite important because you need to know how your application is running, and it you have to know how your application is running, how it is interacting, how it is set up. Because I'll tell you, if a DevOps guy is helping you, a DevOps person is helping you in setting up the pipeline, setting up the interaction, they will not know what your application does. You will know what your application does as a developer. You know exactly how it is going to interact, how much resource it is going to do, what are the cron jobs that need to run in the backend. You are the sole owner of it. So by default, you need to know and you need to guide the person to develop. Yes, I know we are saying that we are reducing. There are when you are matured enough and the platform is matured enough, you will be the one responsible for deploying your entire architecture. But how exactly it is running in your system, you need to know. Not only Linux, to be precise, if you're running Windows-based application, which are completely data-driven application, you need to know Windows, how it is running. You need to be able to help, figure out those errors. So yes, it's important.
Okay, so last question is all about trends. AI is trending. How would you say, what are the latest trends that developers should look out for in the cloud and DevOps domain?
Well, it's how you use it. I believe Amazon Q is already there. I'm just trying to see if they. I just opened the window so that if it shows me that Amazon Q here or not. Uh, AI is everywhere. You cannot see it's a generative AI. Gen AI is everywhere. You cannot escape it, and it actually helps you in deploying faster, in going, in utilizing faster. AI is a very, very good, integration part of AI is in, in your CI part, in where you're integrating specifically, in where you are testing, in your test, and in your, code quality checks and all. Definitely AI comes into picture. Deployment, AI comes into picture, that learning the trends of how much utilization, resource utilization an application is having. Okay, and giving it an idea that okay, this is the time when the utilization happens more or less, and then define accordingly. It reduces your cost. Right now in this level also, everyone is trying that how best we can put in integrate Gen AI. I have seen pretty amazing work being done by Gen AI. One of the things that I know what got deployed is that as soon as you are uh, creating a Terraform code, or you're creating application code, it gives by live in there itself, it gives you that how much resources it's going to use and what is the optimized resource you can define for that application to run, which is pretty amazing in my view. And it reduces that platform have to go in there and check and reduce the resources, reduce the idle resource time much more. That you're putting it at the source itself, right? So these are the things that are very useful. Specific also, AI is coming in architecture diagrams. In fact, you have got to code fabric. You have got your Gen AI, sorry, your Open AI itself. You go in there and ask them to give you an architecture for a solution. It comes in and gives you architecture. Now, how you do it, the base architecture, how much you grow, that's on you. But you don't have to wait and do 200 pages of documentation to find out where it is, what what to start with, the base with. Also, Gen AI plays a major role in your error handling, your alerting, your monitoring. So yes, it is there. It is here to stay, and I'm just going to say that it's going to help the developers, the platform engineers, the DevOps engineers, everyone to do their job way more better.
All right. Thank you for joining us, Somnath, and this was really incredibly insightful session. So, guys, all the the resources shared by Somnath will be available on the Discord community. So make sure you do join us. Also, thank you for joining all the live audience. Please make sure that you tell us how you found this session to be. You're free to share your feedback. You can connect with Somnath on LinkedIn and tell us about your learnings. You can post it on LinkedIn as well. And yeah, join the Rebase community. You will get all the resources about the session there. And share us let's have this conversation going even after the session, and keep the learnings going. So all the, as I again mentioned, the recording and the resources will be shared in the community, so make sure you join them. And yeah, this was incredibly insightful. Thank you once again. Thank you, Somnath. Thank you, Rebase. Yeah,
Thank
happy
you.
weekend.
Yeah, thank you, Kriti. Thank you for having me. It was really nice, and hope I was able to help someone. And yes, if anyone wants to learn more, please do feel free to reach out to me over later. Thank you.
That's all, guys. Happy weekend. Thank you for
Thank
joining.
you.